Hey everybody, today we're going to be proving the quotient rule. And I've done this before using the product rule, but today we're going to use the limit definition, which I've written out here using this is our function plus h, this is our original function, all divided by h. So, let's just begin. I've proven a lot of other derivative formulas, so let's just complete everything with the quotient rule. So the first thing I want to do is I want to combine these two fractions, because once we do that, once we put these two under the same or over the same denominator, we can put this h with that denominator, so we just have a very easy little setup to work with. What we're going to do is we're going to multiply the top and bottom by g of x here, and g of x plus h here. So let's just do that. So we got g of x over g of x, and we have g of x plus h over g of x plus h. Okay. So when we do this, actually, by the way, I'm going to speed up a lot of parts of this video because it's just, there's a lot of long pieces I'm going to write, so just be aware of that, okay? Alright, I'm going to combine the fractions, put this h on the denominator, and then we'll talk from there. Okay, so we have this. And it's, we can't really do much with this, but like we did with the product rule video, we can add something and subtract something from the numerator, and that'll, that when we add and subtract something, the same thing, it just cancels out to zero, but it will help us with figuring out what this is actually equivalent to. So I'm going to add, you can try out a few different combinations, so actually try it out. Which combination would actually help you in working with this video? And if you haven't watched the product rule video, you should watch that to give you some inspiration of what we're going to do. So I'll give you a few seconds to think of that. And yeah, so 3, 2, 1, we're going to use f of x times g of x. Okay, we're going to add and subtract that. Actually, we're going to start by subtracting, then adding it. So the way that's going to look is it's going to look like this. I'll put it in red. And yeah, so let's speed up the video again. Okay, so this is what we have. You can see how these red terms cancel out. And what we can do is we can factor g of x out of here, and we can factor an f of x out of here, and then we'll get some really cool results. Another thing we can do at the same time is split this into two limits, because the limit, if we add terms, we can, the limit of addition is the addition of limits, basically, the way we can look at that. Same thing with division. We'll actually use that in a second, and with other operations, of course, but we're not going to use other operations. So, continuous operations. Okay, so the first thing I'm going to do is I'm going to split this. I'm going to use this as one formula, and then I'm going to use this as the other limit part. And of course we have to include the denominator in both of them. Oh, and I'll factor out the g of x, and I'll factor out the f of x here, okay? Okay, so we've factored everything out. So this doesn't really do much. The only thing I can see is we can cancel out this g of x with that g of x. But other than that, it doesn't look like we can do much. But if you recognize, we have an f of x plus h minus f of x over h, which is actually just f prime of x. So we can actually use that really easily. And then the other thing here is that this f of x, it has nothing to do with h, so we can factor it out of the limit. And then we have a g of x minus g of x plus h over h, which is very, 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 very close to what we need for the derivative of g, okay? The only difference would be this would be a negative derivative of g. So I'm going to do a few things. First, I'm going to write this explicitly as the derivative form, and then I'm going to divide by this g of x plus h, and I'll show you what happens there. And then I'm going to, by the limit of g of x plus h, factor out this, I'm going to factor out this, and I'm going to write this in the form that we need, and then divide by whatever remains, okay? So a few steps here, and I'll explain that when we get there. Okay, so now we have a weird combination of things. So as I said, I took this, I just took this f of x plus h minus f of x over h, took that as one part, and then we saw that g of x plus h in the denominator, so I'm dividing by that. And when you take the limit of a quotient, you can make that the quotient of a limit, of two limits actually. Then I factor out the f of x. Then I did the same thing with the quotient thing here. I took this, I made this the derivative, factored a negative out of here, which we can actually just factor out to the front of this limit, which really just goes here. We can just do that right now. And so then this is just a derivative. I can actually get rid of these parentheses. And then what we're going to do now is, and then we have this division by the rest of this term. Okay, so we can actually get rid of a lot of our limits now, okay? This is just f prime of x over, well, g of x plus 0, because h is going to 0, we actually can really get rid of that now. This is just g of x, right? So this is f prime of x over g of x. I'll give myself a little bit of space there to manipulate the stuff. And I'll put a minus. And then we have, well, g of x plus h minus g of x over h. That's g prime of x. Yeah, so I can do g prime of x, because that's the definition of the derivative of g. Let me make that fraction bar a little neater. Okay. And this is divided by, well, what is this going to be? Well, as h goes to 0, this is just g of x, which we can actually factor out over here, but that's not really necessary. G of x times g of x plus 0, which is just, this is just g of x as h goes to 0. So this bottom just really is just g of x squared. So we have g of x, and we're going to square this. Okay, and so as I said, we're going to do a little bit of manipulation here. So the way we're going to do this is we're going to multiply by g of x over g of x so that we can combine the fractions. So g of x over g of x. Right, we're just multiplying this. Let me give you a little multiplication dot there. Okay, so then we can actually, like, oh wait, what am I forgetting? I'm forgetting something. Oh yeah, the f of x out front. I forgot the f of x out front. Don't forget that, okay? So I'll just do that. So then this, once we do everything, this is all over, this is g of x times g of x, which is just g of x squared. That's the whole point of what we did. So let me just do this, put that on the bottom, oops, g of x, and then we're going to square this. Okay, so our answer is f prime of x times g of x, okay, minus g prime of x f of x, and you can write that in a different order. You can write g times f prime minus f times g prime, or whatever you want, as long as it actually makes sense. But yeah, this is our quotient rule. This is what we were looking for this whole time. And yeah, so we did all of this work, and we actually ended up here. This is great. This is what we needed. And yeah, it's a lot of work, but it's really, it's about the same amount of work as we did for finding the product rule. It's just in a different way because we're dealing with these fractions here, which we actually were able to deal with. And we made it like more complex here, but overall it just simplifies very nicely, and it's really cool. So I hope this gives you a great proof for the quotient rule. I hope this was easy to follow. So yeah, thank you for watching, and I'll see you in the next video. Bye guys.